Here's question number 4. In the triangle shown below, oh, there's a lot of data. So little by little, I'm going to take each piece of data and put it into the figure. So EH equals 24. HF equals 12. The cosine of E equals 12 over 13. So what I'm going to do is, first of all, remember that SOHCAHTOA again. CAH here reminds me that cosine equals adjacent over hypotenuse. So keeping that in mind, that the cosine is the adjacent over the hypotenuse, I'm going to use this information about cosine of E equals 12 over 13. Now, unfortunately, I know for E, the adjacent is right here, is the 24. And the hypotenuse is here. But I can't just take the 12 and put it as the adjacent number because I already know that the adjacent is 24. So what I'm realizing though is 24 is exactly twice as big as 12. So for the adjacent, instead of saying that it's equal to 12, I'm going to say it's equal to like 12x. So let me put a 12x here. And the hypotenuse then, I'm going to take this denominator because the 12 is associated with the adjacent and the 13 with the hypotenuse. So this hypotenuse is going to be like 13x. And then looking that 24 is 12x, I think you can solve that equation in your head and say, oh, x must be 2 because 12 times 2 is 24. So now that we know x is 2, we'll say 13 times 2 is 26. Oh, I know what the hypotenuse is. The hypotenuse is 26 here. Okay. What is the length of FG? I'll get all the way here to the other end of the triangle. So one thing I'm noticing right away are those numbers 12 and 13, and then I have them in their doubled forms, 24 and 26. That should be, when you're working with the right triangle, those numbers should jump out at you as being 2 parts of a Pythagorean triple. Remember, a Pythagorean triple is 3 integers that can form a right circle. In other words, 3 integers that make the pattern a squared plus b squared equals c squared. And it's really, really helpful to memorize the 5, 12, 13 Pythagorean triple. That means if you have 2 of these 3 numbers, you can always just get the third number, not by doing the equation, but just by remembering it. So I'm seeing that already here. I'm seeing a multiple of 12 and a multiple of 13. So I know this last one is going to be a multiple of 5. That's going to be my 5x. And I already figured out that x over here is equal to 2. So HI is 10. I don't think that we needed to find HI for our final answer, but I think we might use that. Now I've got to get, right, FG. So let's look at this. From 24, so 24 is part of sort of like the tip of the iceberg here, just the top of the triangle. And the whole triangle, the whole iceberg, is going to be 24 plus 12, that's 36. In other words, it's 12 times 3. So if we're going to go from 12 times 2 to 12 times 3, I'm going to go on this other side. I'm going to base it here on the multiple, on the side that's the multiple of 5. So if this one is 5 times 2, over here I want 5 times 3, or I want 15. So what I just did was I used sort of the tip of the iceberg and the whole iceberg, looked at them as similar triangles, and I set up a proportion. This tip of the iceberg had a 24, and the whole iceberg had a 36. On the sides where I had my unknown, the tip of the iceberg had a 10, and the whole iceberg, well, that was my unknown. That was what I was looking for. You can solve that by cross multiplication. I actually found an easier way to do it in my head, but if you have a calculator, go ahead and cross multiply to solve for this variable. What I did was I reduced this fraction. 24 over 36, they're both divisible by 12. That's 2 over 3 equals 10 over what? Well, now we can say 10 times what is 2? 10 times 5 is 2. So what times 5 is going to give me, 2 times what is 10? 2 times 5 times 10. So 3 times 5 is going to give me 15. And that was another way to get to the 15 without actually having to use your calculator.